Lesson 10-2 continued. We are now going to take these radicals and we're going to add variables to them. So kind of the general rule here is if it is an even exponent, they are automatically perfect squares. And the square root of those would be the exponent value divided by 2. That's how you do the square root. So if it'd be something like x squared, then the square root would be x. If it would be x to the 4th, the square root would be x squared. If it'd be x to the 6th, the square root would be x to the 3rd. You take the exponent divided by 2. That's how you do the perfect square. Now, if it is an odd exponent, those aren't perfect squares. So you must subtract 1 from the exponent because it's got to stay inside. Okay, it's just like a number that's not a perfect square. The leftovers have to stay inside the radical. So you take 1 off, and then that would make it an even, and then take that out. Also, this is kind of the thing that's kind of weird, but you got to remember, if it is an even power inside, but it comes out as an odd power, you got to be careful because of negatives. If that happens, an even power on the inside, and it comes out as an odd power, so that means a squared that comes out as a plain 1, you must put an absolute value sign around it to make sure we do not get incorrect signs. So the example that I'm showing you there is a good example of what we mean. If it would be x to the 6th on the inside, and you bring it out, well, you take 6 divided by 2, that's x to the 3rd. So it was an even inside, came out as an odd. Those must have an absolute value symbol around so you do not get incorrect negative values. Okay, so here's the deal. Example H, radical 45, a to the 4th, b to the 5th, c to the 6th. You take everything and break it apart as far as perfect squares are concerned, just like this. 45. Well, 45 would break into the factors of 9 times 5. A to the 4th, that's a perfect square. It stays a to the 4th. B to the 5th, that is not a perfect square, so what you write is this. B to the 4th times that extra b, because that's the one that's staying inside. C to the 6th, well, that's fine because that's even. Okay, here's what's going to happen. I'm going to take and do this a little quicker than what we've been doing. Anything that's a perfect square, I'm going to square root it and write it out in front. Anything that's not a perfect square, I'm going to leave it under the radical sign. So I'm going to go left to right. There's the 9. The 9's a perfect square. What's the square root of 9? 3. So 3 comes out in front, and I've taken care of the 9. Then there's the 5. 5 is not a perfect square, so it will remain in the radical. A to the 4th, so the 5's taken care of. A to the 4th, that is a perfect square, and it would come out as a to the 2nd. Done. B to the 4th, that is a perfect square, so it comes out as b to the 2nd. That extra little b, well, it stays inside. It's left over. And c to the 6th, it comes out as c to the 3rd, but it was an even power coming out as an odd, so it has the absolute value symbol around it only. And that would be the end of that. Questions? Olivia. Every power, you divide it by 2. The evens divided by 2. If it's an odd, you got to keep a leftover in there. All right, one more. Radical 32, m to the second, n to the third, p. So let's try to split apart all the perfect squares. So I've got the 16, or I'm sorry, I'm thinking ahead. Got the 32. So you're definitely going to go 16 times 2. M squared is already good to go. N cubed is not. So you break it apart to an n squared and another little n, and p, sorry about its luck, it's just going to be stuck there. Okay, I'm going to draw the radical, and I'm going to go again across left to right and pull the perfect squares out, leave everything else inside. So I've got the 16, perfect square. Bring it out in front, 4. The 2, it's got to hang out inside. M squared comes out, you take 2 divided by 2, so m to the first. N squared comes out as n. The extra n left over stays inside. The p by itself stays inside. One last thing, the m and the n are 2 odd powers, so I'm just going to put it all in radical or in absolute value just like that. And you are done. So again, anything that would be to an even power that comes out to an odd power, put it in an absolute value symbol. That takes care of any accidental negative values, and everything else is left inside the radical.